Okay, now let's take an example of ammonia to see how the titration uh, is is done. Okay, the EDTA titration in presence of ammonia, yeah, whose concentration is 0.10 molar, right? As I said, yeah, this concentration is a really high concentration. Consider titration of 50 milliliters of 1 molar zinc ion with 1 millimolar EDTA at pH 10 and find pH zinc values after addition of 20, 50, and 60 milliliters of EDTA. In this case, the first thing we have to do is to find the equivalence point. Here, let's see. Since zinc and EDTA concentrations are the same, so uh, the equivalence point is 50 milliliters of EDTA solution. Okay, yeah, here, very easy. Yeah, and we get the effective conditional formation constant Kf double prime, which is alpha zinc, alpha y 4 minus, and Kf. Okay, all the multiplications, and it gives alpha zinc is already calculated. When alpha y 4 minus is 0.3, and alpha Kf is 10 to 16.5. Yeah, and then Kf double prime is 1.7 times 10 to 11. Wow, so you have to be amazed. Wow, even uh, the multiplication of alpha, these two alphas, right? Still, this effective conditional formation constant is very high, right? 10 to 11, right? This is really high. So titration can be done, yeah, virtually can be done without any problem. Okay. Now let's consider the P zinc value uh, when 20 milliliters of EDTA is added, right? This is the before equivalence point. Okay, and then we calculate the free zinc ion concentration. Okay, by the added moles of EDTA, now zinc is well zinc now, yeah, most zinc ions are complexed with ammonia. Anyway, the free zinc concentrations is what? Since 20 ml was already 20 ml is already removed by zinc, and the free zinc ion is what? And 50 minus 20 and divided by 50. Okay, and this is the factor, the dilution factor. Yeah, and let me see. This is concentration of the EDTA, yeah, standard solution, and uh, free zinc ion concentration is 4.3 times 10 to minus 4 molar. Okay, yeah. But here, however, nearly all zinc not bound to EDTA is bound to ammonia, right? Now, so we have to you have to recognize that even before EDTA is added, all zinc ions are complexed already with ammonia, right? Because ammonia, let's say, concentration is very high, and with respect to zinc ion concentration, which is only 1 millimolar, right? 100 times higher. Okay, so although we calculated free zinc ions, yeah, this free zinc ions are already bound to uh, this one, ammonia molecules. Okay, and here using this equation for using the equation for alpha zinc ion, and then we have to find the free zinc ion concentration here. Okay, it is given by this equation. Okay? Alpha for zinc free zinc is 1.8 times 10 to minus 5, and here the free zinc ion, when you assumed that no ammonia molecule, which is 4.3 times 10 to minus 4, and then the free zinc ion in this case is 7.7 times 10 to minus 9 molar. Okay, and P zinc is 8.11. Okay, and then let's see let's have the reality check. Without ammonia, zinc, at the pH 7, zinc ion makes complex with hydroxide ion. Okay, and then this one, this calculation, zinc ion plus multiplied by hydroxide ion squared is what? 10 to minus 16.11. Okay, wow, this one is very small, even smaller than KSP. You see, for this one, from the appendix, you can know the KSP for zinc hydroxide, which is 10 to minus 15.52. Okay, since this concentration is much higher, lower than KSP, which means no precipitation there. All right, yeah, this is important. Okay, yeah, you understand? Okay, let's go on. Let's consider the zinc concentration at the equivalence point. Yeah? And at this point, all zinc ions, okay, are complexed with EDTA. Okay, and this EDTA zinc ion complex concentration is what? Just half of zinc initial zinc ion concentration, right? Because the zinc ion and the EDTA concentrations are the same, okay, and which is 5 times 10 to minus 4 molar. Okay, and then we can write it this way. Okay, this one, we start from zinc EDTA complex, and then it dissociates, although small, into free zinc and free EDTA here. And then we use the effective conditional formation constant, in this case not conditional formation constant. Pay attention to here, Kf double prime should be used. Why? Because although zinc ion is delivered from zinc EDTA complex, and then this zinc free zinc ion is again complexed with the ammonia molecules. Okay, and we have to use this one, and here, and we write, this one is already known, this 5 times 10 to minus 4, and then minus x divided by this one. These two species are the same, right? Just exist in the same concentration, and we can set up the equation, and then we solve for x, which is a zinc ion concentration, and it is 5.4 times 10 to minus 8 molar. Okay, and here this is free zinc, but again we have to you have to calculate this free zinc. This is total zinc ion concentration. Okay, free zinc ion concentration is given by this equation, and then you get 9.7 times 10 to minus 13 molar. Okay, and P zinc is 12.01. Okay, so here you must be careful in calculating the free zinc ion concentration in the presence of ammonia and at the equivalence point. Okay, finally, yeah, let's consider zinc ion concentration after the equivalence point. Now, when EDTA solution of 60 milliliters is added, okay, and now almost all zinc is in the form of zinc EDTA complex. Okay, and zinc EDTA complex, what's the concentration, and this is dilution factor. Yeah, and then initial concentration of what? EDTA or zinc, yeah, which is 4.5 times 10 to minus 4 molar. And what is the free EDTA concentration? Yeah, here 10 ml, yeah, 10 ml EDTA is free, okay, and 10 divided by 100, 10, this is the total volume, and multiply by zinc ion EDTA concentration. Now it is 9.1 times 10 to the minus 5 molar, okay? And use this one. In this case, you have to use Kf prime, conditional formation constant, not Kf double prime. Why? In the presence of excess EDTA, the ammonia effect doesn't exist anymore, okay? Because EDTA is a more strong complexing agent with zinc, right? So we use this equation. Okay, this is a conditional formation constant, and this is this value is 9.5 times 10 to 15, and we already obtained this one, zinc EDTA complex this concentration, and also free EDTA total free EDTA concentration here, and here zinc ion concentration is calculated to be this one, this value, very small, and P zinc value is 15.28, right? Okay. Note the past equivalence point. The problem did not depend on the presence of ammonia, right? As already explained. The greater, this one, auxiliary complex agent, the smaller the change of this one, zinc ion concentration. Okay. So the concentration of auxiliary complex agent must be kept low, right? The level that would obliterate the end point right here. This is this figure shows that very well. Okay, let's see. For the two different auxiliary complex agent concentrations, one is 0.1 molar, yeah, which is we just considered, and the other one is 0.02 molar. Okay, and what's the difference? If the auxiliary complex agent concentration is high, and then the step size, step size in P zinc is becomes smaller when this ammonia concentration is lower, and then the shape is the same, but the step size is big, and this one initial P values are different, okay, and but after the equivalence point, the the curve is the same. Why? As I said, after the equivalence point, only EDTA effect prevails. Okay? EDTA is dominant because EDTA is a much more stronger complexing agent than ammonia. Okay, but this part is the same. But initial, this p values, p metal values are different. Okay, yeah, this is the conclusion.